Hello everyone, so I'm going to be going over today's contest, Codeforces Round 806, and this is going to go up like quite a few hours after the contest actually ended, so by now you might have already gotten like a grasp of the solution, but I'm just going to give my take on it. And yeah, I'm just going to wait for the problems to load. And I solved unfortunately, I only solved questions A through C in contest, but then later I upsolved question D. So I'm going to be explaining questions A through D. Let me open, OneNote. Okay, so the first problem, yes or yes. So you're basically given a string, or so you're given a test case, like number of test cases, and then for each test case, you have to output whether that string that's given is equal to yes. And then the case doesn't matter, so um, basically meaning that you can have lower cases and upper cases in any combination, but as long as there's a y, an e, and an s, then you have to output yes. And if there's anything else like a z or ors or anything, then you have to output no. And this is pretty simple. I mean, it's just like testing how well you know your language's syntax. And for C++, basically, let me just go right to the code. I don't think I need to explain anything further. Basically, you can use like the C++ function to lower, and then I'm pretty sure it only works on characters, and so I just replaced the whole string with the lowercase version of it, and then I think I went over the syntax last video, but I'll just explain it again. So this what this does is it checks if this condition is true, and if it is, then output this. Otherwise, output no. And so yeah, that's pretty cool. So going on to question B, ICPC balloons. So basically, you're given test cases and also a string. And then in that string, if you're the first team to solve a problem, and it's denoted that you solved a problem if you're the first, or you solved a problem like let's say A and no one else before that solved it. So if you're the team that solved this problem, then you get an extra point. But if you're the team that solved this one, you don't get an extra point because someone already solved it here. So originally, the number of points would be equal to 3 because that's like the minimum number of points. And then to look for unique numbers, so basically we're just finding unique numbers. The bonus is the amount of unique letters. Sorry, and right here only A and B are unique, like these two, and so you'd add an extra 2 onto the 3. So let me show you. So let's say we have the first test case. Let me draw it out. So we have an a B, and another A. So in the problem, um, yeah, they ask you or they give you like a string, and then if you're the first team to solve that problem, you get bonus points, and instead of 1 point, you get 2 points. So that's what bonus point means. And then to check if you're the first team, basically you just look for unique numbers or unique letters. Let me stop messing that up. And then so that would be this one, and also this one, A and B, and this is not unique because A is already seen here. So that's what unique means. And let me get to the code because this was also pretty simple. I just set a set, and then for each one, if there isn't that letter in the set, then I add one, like the bonus one. So this whole part is like checking if there's a unique letter, and then it adds one to the answer. And otherwise, it just adds one anyway, because then that would be like normally solving a problem. and then I insert it into the set. And what a set does is it's like a container, and it keeps track of like a certain element, and then if an element is inside it, then it outputs yes, so it returns a boolean value, or not output, but it returns yes or 1, and otherwise it returns 0. And so it's a pretty neat data structure. You can initialize it with this, and yeah, so it basically checks if a letter's not in the set. So let's try run the first test case, and so that would be ABA. Yeah, so the string's ABA, so it checks if A is not in the set, and it isn't. And because it's unique and it's not in the set, then it adds a bonus. It adds a bonus point into the total amount of points, and then after that, it just adds another point because you solved the problem. And then it adds it to the set. So next time we encounter an A, then it won't count it over here. And moving on to question C. Let me delete this real quick. So basically what this question's asking is it gives you test cases again, and then an integer n, which denotes the number of like lock numbers. So let's say, so you see like this 8901, so that would be n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. So in this real life picture, n would equal to 4. And the next n numbers is A, and then what A is like the current combination lock. So right now, like it would be 931 as the lock displayed, or the combination displayed at that current moment when you're starting. And then, oh sorry, scrap that. So that would be like after we apply all these moves, and then so basically what we have to do is we have to reverse it in order to find what it was like in the original like combination. And we can see that it says, it shows the second line contains n integers, the digit shown on the ith wheel after all the moves have been performed. So basically this is like the final combination, like what it looks like after everything here has been done. And we're given another n lines, and then in those lines we're given a number, and then like a set of moves that was performed. And so in this case, like the first line, it's D D D, and we know that this was this happened in order to output this. And so what we do is we basically reverse it, and if there's a D, then we make the number go up. So it's like instead of D, like we reverse it to U, and if it's U, we reverse it to D. I hope that makes sense, and I'll even draw it out right now. So we have a 9, we have 3, and we have 1. And then we want to get, okay, so this is after all the moves have been used, and then we want to see what it was like before everything here happened. And so what we do is we're given that, so since there's n lines, each one corresponds to the index, like its respective index. So let's say the first line is tied to 9 because it's the first one. Basically, this is tied to this. So this one moved, like this combination cell moved 3 units down in order to get to 9. This one is tied to this one, and this one's tied to this one. It's the same for each test case. When it's 2, this one ties to this one ties to this one, and yeah. And so basically what you want to do is that if there's a D in the string, you want to make it go up. So if it's 9, then it goes to 10. But look over here. If it's equal to 10, then it becomes a 0. So basically it only goes from 0 to 9 inclusive, and it doesn't ever go to 10 or -1, which makes sense. And in order to implement that, we have to be able to create like something that says if this is equal to 10, then we move it to 0, and if this is equal to -1, we move it to 10. And I'll show you the code in just a second. But let me explain like the rotating part. And so yeah, so if this is a D, like we move it up again because it's basically reversing everything. And then so this becomes a 10, and then 2 extra times, so into a total of 3 times it moves up. So 10, 11, 12. But then we know that since it can't be 10, it has to be 0, 1, and 2. And so we end up getting 2 as the answer for the first cell. And yeah, that's exactly right. And I won't explain the other like combination parts because I think that's self-explanatory. And so yeah, basically what my code does is I created a pair with an int and a string, and then I inputted everything, inputted the int and the string, and then so yeah, that's the pair is like a neat data structure because like you can kind of like do cool things with it and then like put things together. And yeah, this is how you initialize it, and this is how you input it. You do like the first and the second keyword. And so what I did was for every combination, like for every 9, 3, and 1, like every cell, I looked over the string, like the ups and downs, and then I reversed it. So if it's a D, then I added it instead of lowered it, and otherwise, if it's a U, then I subtracted it. And I used else instead of else if because there's only 2 possibilities, down and up. So if it's not down, then it must be up. And if it ever equals to 10, I set it to 0. And if it ever equals to -1, then I set it to 9. Basically, it's like pseudo looping it. And if it ever exceeds the limit, I like push it back down. And if it ever goes like too low, then I push it back up. And then this is like a for each loop. And then for each element in the array A, I output the element. And yeah, that's my code. And moving on to the last question, question D. This question it was like a bit of a toughie because then I got quite a few time limit exceeded, but I was able to upsolve it at the end. And yeah, so what it does is it gives you a bunch of strings, and then your goal is to see for each string if it can be created using 2 other strings, then then you can turn that bit into 1. So, for example, in the first test case, it's AB, and then you can use AB, you can use the strings like twice, and since AB is already here and you can use it twice, then AB plus AB is equal to AB, and this is equal to 1. Let me draw it out to make it easier. So, let me erase this first. Basically, for each string, you want to check if it can be created using 2 other strings of any combination. So it can be this string twice, this string plus this string plus this string. But then the time complexity turns out to be massive because then if you do it in a like naive way, so if you wanted to create like a triple for loop, which I would not recommend, it would end up being O of n to the power of 3 because then you wanted to check if this is equal to this, and then or if this plus this is equal to like this or something. And I tried other optimizations, but then I figured out like the real solution is to use a function called dot substring or dot sub str. And So the way I did it was like for every string over here, like for every string, I added it to a set, and then here, let me double check my code. Yeah, so basically I added it to a set, and then I created a separate string answer, and then I created like a boolean variable, and then what this part does is it goes through all the letters of that string, of that current string, s sub I, and then if so what the syntax does is it basically checks there is a uh, if there's a substring from 0 to like j, which is like constantly increasing, and then also from j to on. So let me show you what that does. So if we have a b, what that syntax does is it checks if it goes from here and then also here. So two separate checks. So this a is the first part, like right here. So it checks from 0. So what dot substring does is it goes from like the specified index, which is 0, and then to like how many letters. So j would be one letter in the first loop. It would be one letter, so it would go from 0, which is this index, and one letter, which is a. So that would be a. So it checks if there's an a, and then also a BAB, because what the second part does right here, j, if there's only one argument, then what it does is it checks that index till the end of the string. And so that index would be 1, so that'd be 0, 1 over here, this b, all the way to the end, which is what that does. And that approach was so much faster because if you look at the constraints, I mean, looking at the constraints is always important because you can see that the string length is at most 8. So the operations would be very minuscule compared to a nested for loop, which could be 10 to the power of 5 times 10 to the power of 5, which is a lot of moves. And yeah, so that's what it does. And if they are in a set, you can output 1, or I mean you can turn the boolean variable to 1 and then break. And if OK is equal to 1, then you add 1 to the answer. And here, let me show you. So it checks ABAB. What this does is checks ABAB, and it sees that AB is in the set, and then also AB is also in the set, because this is in the set and this is in the set. And because they're both in the set, OK is turned to 1, and when OK is turned to 1, you can add the character 1 to the answer. And that's basically what it does. And just a tiny little detail, the reason why I used a string and characters for the answer is because if you ever add like 1 and 0, it just adds up numerically. But if you add it with a string, it ends up being like, if you add like string literal, sorry. Yeah. If you add a string literal, a 1 plus another string literal of a 1, then it becomes, or a character literal, I mean, then it becomes a string literal of like 11. And so that's why I did it, because over here it's only boolean values, and so I wanted to like stack them, like think of it as stacking and not combining. And yeah, so that's it, questions A through D. And if you guys have any questions, you can always comment down like questions, and I'd really appreciate it if you enjoyed the video. Like it would be nice if you could like the video and also subscribe, and thanks for watching.